So I've got the proper linear regulators in now, and I need to remove the old one. So this will be my first ever PCB repair. It's kind of funny thing to think about considering it's also my first PCB build, but there you go. That probably isn't a surprise that they go hand in hand. Before I jump into that, a few things. First, the DJI camera that I was using to try to film the PCB, I like this camera. I'm not shitting on the DJI, but it is crap for trying to look close at something. Macro filming? I don't know if that's the right term for that, but anyways, I apologize. The last video or two, the quality of the PCB was shite. So I have something I'm going to try with this video that will hopefully work better. And it's another reason I love the 3D printer. I have this frame that I designed. I've got an iPhone 14. It's the mid-grade one, not the top one, so it doesn't have the super fancy cameras, but I'm hoping it's going to do a better job of filming the PCBs. Now, I mocked up this little stand, and I have a couple of sliders. And if I was doing it again, I would do it a bit different, but the idea is that I can put the camera up here, put the PCB down here, and hopefully it's going to suck a lot less. I'm learning. We'll make it better as we go. So that is the chip I need to change, but I have to be careful not to melt these. And the way I'm going to do that is with this metal tape. I heard that you could use Kapton tape as well, but I saw a video where somebody was testing reworking a board with the Kapton tape and with the metal tape, and the metal tape did a much better job about preventing the components around it from being damaged by the heat. So there's my piece. I'd like to get a little bit of a fold at the bottom just to help keep the heat from getting underneath. And hopefully that will protect the capacitors. Unfortunately, this has a big copper pad it's hooked to, so I fully expect this is going to take a bit. Here we go, got it. I got to clean that up. Yeah, did I do any damage to this? No, looks fine. There you go, these capacitors are fine. I've seen this cleanup done before on videos, but it'll be the first time I'm trying to do it myself. Okay, I have to turn the fan on. It's going to be a little tricky hand soldering back there with these capacitors in place, but this is exactly what I need to practice for on the boat. Okay, pads are tinned. The hot air would probably be the easiest. Gosh, the folks on YouTube make this look easier. Okay, this is not working. Well, I think it actually did. I should be using the smaller tip here, I think. Okay, I give up. I'm going back to air. Absolutely going to have to keep the air on the boat. I'll switch over to paste as well, so I'm going to take this off again. Honestly, as it is, this would probably work, even if it's crooked, but my OCD will not let that stand. I don't have OCD, by the way. I know people who have real OCD, and it's serious. Oh, something's smoking. Did I ruin the capacitor? Nope. Must have just been some flux or something. What I've been doing with this, seeing as the plunger doesn't work, I scoop it out and manually place it on the pads. It is slow and frustrating, but this stuff was expensive and I don't want to waste it. Let's see if third time's the charm. Okay, I think it's gone. I can see a bridge back here. There we go. Let's tone it out. Okay, so the bottom one is ground and the shield is ground. That's good. 3.3 is connected, and I think the top one is 5 volts. Okay, 5 volts is good. So I ran into another problem. It's not a huge one, and it's one I accidentally fixed by making what I thought was a mistake. Let me show you what I mean. I didn't properly understand what an NMEA 2000 cable was. I looked at the back of my, I have a Icom IC-M510 Evo, I think it is. If I'm wrong, I'm putting the right one here. And I looked at the back of that and I saw the connector and I checked it online and I thought, okay, I need an M12. I didn't realize there was a type A and a type B. So when I developed the boards, I was using these connectors and I bought this cable to do my initial work, which worked. Now, the first problem I noticed is that after I built it, there's no thread on these. The back of the radio and other NMEA 2000 devices I've seen have this threaded connector on it. So I thought at the time, okay, well, I just got the wrong connector. I need to get the connector that has the thread on it. When I went online looking for the right connector, I thought, okay, well, that's fine. I'll just find this, but with the thread on it, and I'll swap them out. But I couldn't find any anywhere. So I ended up buying these connectors. Now, you'll notice they're on a pigtail. They're not designed to mount directly to the circuit board. And then a couple days ago on Sunday, I went down to the boat to actually get the actual NMEA 2000 stuff. So later I'm going to do a video specifically on NMEA 2000 showing what I've learned so far. Once I know I've learned it right, which clearly I haven't yet. But one of the things you get is you get this power T, which goes to what would normally be your positive and negative 12-volt bus on the boat. I've currently got it sitting in this clamp to make sure I don't short the positive 12 and ground coming from the bench power supply. That provides power to the entire bus, and then you have drop cables that go to the actual devices. So off camera, I've been working on a couple other boards. I don't plan for the channel to be a watch Maddie build everything electronic for the boat. That would get boring. Where's the, oh hey hun. I don't even know if the camera can see you right now. Oh, gesundheit. You gotta be careful not to roll over your tootsies. So, off camera, I have been working on the compass rose. I printed a frame that is going to glue into the smoked plexiglass and a frame for mounting all of the LEDs to keep it flush with this. So this frame will get glued to the underside of the plexiglass, and then the PCB will be pushed up and screwed in. And if I need to service it, I can just undo these screws and the PCB and the ring and the LCD drop away. The point is, I fully built this board and I wanted to plug it in to see if, I don't know if you can hear that, but she's like sneezing constantly. Yeah, right there, hon? Do you stick your nose in some pepper? So I wanted to plug this in and just see if things were working. And I noticed when I tried to plug it in, dramatic recreation on the relay board, it didn't fit. And I had a moment of sadness. I just showed you the right connector. I have not left this seat. I cannot find it anywhere anymore. It is gone. This minor inconvenience feels like an absolute tragedy. I guess I'll just open another one. Thankfully I bought 10. So with these that I bought thinking I wasn't going to use them, it turned out those were the actual NMEA 2000 cables. So what I ended up doing is I ended up 3D printing a standoff. So I mocked up and designed this little 3D print that has, can you see that there? A couple of screw holes in it. Can you see the two little black clips that hold this connector on before it gets soldered into place? So I ended up taking the old connector off this one and soldering this on in its mount. So now, even though it's not technically PCB mount, it's chassis mount, it's basically PCB mount. Now, because these are going to be mounted to the underside of the plexi and they're going to be inside of the helm cabinet, I hadn't really decided whether I'm going to make another box that actually covers the back of the PCB. If I do, I left enough of the lead length that I can move these NMEA 2000 connectors to another part of the chassis. Now, separate question please. I went through with IPA and cleaned all of the flux off the board. And when I was done, I don't know if it's coming across on camera, but it left this tacky goo all over the board. It's almost like the IPA broke down the flux turned it into a nice smooth spread, spread it all over the board, and then evaporated, which it's aesthetically unpleasing, but more, it makes me worry that when I do the conformal coating, which I'll do right before as part of the final install, it won't stick. So if anyone has advice on how to do a finishing clean on PCBs, can you please leave it in the comments? I would much appreciate it. Like, is acetone the way I'm supposed to go with that? Anyways, that is not what this video is about. That's just me asking for help. So, I had made the same mistake on the main board. I had started to bring up this board, and this one I was doing the right way. I brought up just the 12 volt, verified it was working. Then I brought up the 5 volt unisolated, verified it was working. Then I did the 5 volt and 3.3 volt isolated and verified they were working, which means that the new linear regulator is in fact the one I need. So with 2 boards practice, let me show you how I'm doing it with a third. It is kind of brutal, but I tried hitting the underside of the connector with the hot air gun for a long time, and I turned up the heat to like almost 400 Fahrenheit. I don't know what that is in Celsius. I was going off by the reading, and I just could not get the solder to flow. So what I ended up doing is just hacking the whole top off and then just heating up and pulling each pin at a time, and it worked. I mention that because for once, you're gonna see me do something with at least a little bit of experience. Let's see if I can do this in front of the cameras. So the first thing I do is I clip the legs. That's the other leg cut off. This is, I'm gonna almost certainly have to bend out of the way, so I might as well just do that now. From the back, I can get here and cut these 2 now, but it's not gonna do me a lot of good. I might as well just cut the whole frame off. Whee, pieces go flying. Now, I'm not too terribly worried about saving these because now that I know that they're not Enemy A2000, I don't see myself ever using them again. Okay, yeah, this is a lot harder trying to do this in front of the camera. There we go. I'm sure folks are yelling in the comment section, if you did X, it would be easier. Please tell me in the comments how I could have done this better. There we go. If I add solder, it would go easier, and I know this, but then I have more solder to get rid of later. Let me get the fan going. And I'm getting into the bad habit already of forgetting to put my wrist strap on. I need to not get into that bad habit. I know it's probably okay because the mat is grounded, and I'm touching the mat constantly, but still. There we go. That's 2 out. There we go. Got it. That's 4. 5. So now I need to open these holes up. One is open and the others are blocked. I was experimenting with different ways to get that out, and the way I found worked the best so far is flux and braid. So yeah, I took the braid and I curled it up to be the right size to fit in the hole. Added some flux, stuck it in, and heated the braid, and it actually worked fairly well. There, now it's fully clear. There. You can kind of feel when it drops in. And of course, I need to say this again. This is not a tutorial. I do not know what I'm doing. I am figuring it out as I go. Okay. Let's check it out on the other side. That is not great. It looks like I peeled the copper trace off the circle. It's still good on this side, so it'll make a connection, but this is definitely not going on the boat long term. It'll go on the boat for launch, but it won't go on the boat for long term. I always knew that was going to be the case with these boards anyway. Oh shit! I ripped the trace right off that. That's the can high, or can low. It's one of the 2 cans. The center one is one of the 2 cans. All right. That looks like it goes to this pin right here. So for the sake of this board, I might just tack a trace on. So for sure, this pin is damaged. And I was right, it goes to that bottom pin. So if I tack a wire here, and I run it in, and I join it when I bring the other wires through and solder it all together, that bodge wire will jump over that trace. This one, which I tore the trace off of, it is actually connected on the back of the board. You can see here, and that one is fine, so that's okay. So it's just the center one that's damaged that I need to worry with. Okay, I can deal with this. This is what I meant when I said I'm okay with bodging things and breaking things and making mistakes. That's all part of the learning process, right? Just so long as I don't completely ruin the board. I need to make that connection without bridging. Try to do it in front of you if I can. Okay, it feels connected. I probably should have stripped this end first. Oh well, woulda, coulda, shoulda. There we go. Now I could put that through the hole, or I could directly connect this to the end of the wire. I don't know if I'll be able to get both wires through. Okay, feels good. If I can put both wires through the hole, that'll provide a mechanical anchor for this and it won't tug on that pin. So one of the things I had to do is I had to create a list of which colors for this went to which pins. NMEA 2000 has a color code. This doesn't match it. So the brown, white, blue, gray, and black are this cable's color coding, not NMEA 2000 color coding. Okay, you know what? I'm just going to peg those together. Bypass that entirely. Really don't want to rip this off. You almost certainly have a better view of this than I do. Okay, this is not carrying any real current. Let that cool for a second. Okay. Ugly as smuck, but it works. And this, by the way, one of the reasons I'm not too upset by this is exactly the kind of problem I might be trying to solve on the boat. So as frustrating as it is to damage that trace, I'm kind of feeling like this is practice. The last thing I'm going to do before I do the others is I'm going to pull that over and tie it off to the leg of that diode. How exciting is all of this? It's so terribly exciting, isn't it? I've already cut and tinned the wires. Now, this is only 250 kbps, which isn't very fast, but one of the folks in the Discord channel suggested that I twist the cables anyway. Will it help? Maybe, maybe not. But as he put it, when you're dealing with a control system that's moving the boat, and you've got a 5-watt radio, 6-watt handheld VHF radio, it doesn't hurt to be a little overly cautious. So I am going to do that. Now, it's going to be a little bit trickier, because as you can see, I've zip tied this off, so this wire is now bonded to the leg of that diode. So I'm going to have to twist it, just wrapping it. It's not going to be great, but I'll do my best. Can high and can low is gray and black. Kepler is absolutely losing his shit. It's kind of adorable. Yes, I'm talking about you. Okay. I don't know if you can hear that, but I didn't do this twist on the other two. It was showing the patrons those pictures that brought that conversation up. So I'm not going to go back and redo the ones that I've already replaced the connectors on, because those boards are likely going to be replaced before I start traveling. I also should look at adding ferrite chokes, but I don't want to just stick it on everywhere. I need to understand better how the ferrite chokes work and where to put them. If you've ever torn apart a network cable, they have twisted pair as well. They're running at much, much higher speeds, so it's more important with those. But the idea behind it is you don't have any two wires sitting beside each other for very long. So if one's generating a magnetic field, that magnetic field isn't going to have, it's not going to be sitting close to another wire that's high generating magnetic field while the first wire is low, potentially receiving that magnetic field and raising the voltage to the point where it's now read as a binary 1. Okay, so now I can flip that over and solder it. Okay, so I originally bought this box of screws for mounting the LCDs, but they've turned out to be super useful for things like this as well. I'm going to try to do this so that you can see it. Have I mentioned lately how much I love that 3D printer? Huge thank you again to the patrons. I asked them for permission. I mean, that sounds weird. I was going to buy the Airmar weather station because I wanted to do data collection and make that available to patrons. And I asked them at the time if they mind if I bought the 3D printer when I thought it was... I was worried it was just going to be a toy. It has not. It has been a lifesaver so many times, and this is just one more example of that. So it's obviously a little bit funny because of that bodge I had to do, but you see how this has got the O-ring? Normally that would seal against the back of the case to make this ingress protected. When it's just a loose connection sitting on the back of a 3D print though, I'm not gonna say that's gonna stop it. Okay, why are you not going in? Ever seen the meme where they had like a locked gate and the fence was missing on both sides? It's kind of what this is from an ingress protection perspective. Hey, there we go. No sense killing it. I just wanted to... This just has to be strong enough so that I can push the NMEA cable on and pull it off without breaking. That's a 4mm wall. You can see how there's an angle there. So you can see the shape of it there. And that's actually fairly sturdy. The only thing I don't like is the two screws are right at the front. Those holes are not big enough for even these tiny screws, so I couldn't put the mounting holes back there. It's perfectly fine on insertion, but when I go to pull it out, the back of this leg is not held in place, so when it wants to torque, the screw's right there. I hope that makes sense. Anyways, again, this is temporary. So you've seen me tone things out before. I'm not going to do that on camera again, because I don't want to make this too boring. But I'm going to tone it out, and if all the wires look good, I am going to bring it up online, check the voltages like you saw last time, and then try programming it. This is my first board, and I can already tell you, there's so many things I know I could have done better doing it a second time. These inline ICs, I don't know if you can see, but they're not sitting flat. Adrian's Digital Basement, I was watching one of his videos, and he uses blue tack for holding these pins in place when they're being soldered. I didn't do that, so they're kind of like melted and gross. Again, I knew that my first board was going to be something I would look back on and go, ew, and want to replace it, and that's also the reason why it's only got one relay on it. I'm gonna get to testing, and then I will be right back. So I just had a double failure. I had set up the DJI, I had set up this camera. I thought I had turned both of them on. I turned neither of them on. Go me. So the NMEA 2000 is set up, and it is powered by the Raiden at 13 volts. Obviously, I've already powered it up. I can tell you it works, but I can show you as well. I'm going to go to ship ground. You can see this here. I'm putting out 12.99 volt. I am reading 13.03 volt, which is a bit weird. You would expect the load to have less. But I'm going to just assume that's inaccuracy in one of these two. The 5 volt is 5.035, and that's the non-isolated 5 volt. Now I'm on the isolated. The isolated 5 volt is 5.001, which makes me want to believe this is what's accurate, because that's a nice accurate voltage. And the 3.3 is actually 3.319. Someone in the comments, and I'm going to put their comment here because it was absolutely hilarious, said, when I said in the last video that I'm going to try to write a little Hello World script to see if it's working, they said, do you mean Hellorld? Usagi Electric, who is an absolute madman when it comes to computer stuff. He revives and gets working like old, very old, like going back to the 60s, big iron computers. So he built like, I think, an entire relay computer at one point. Like this guy's just, he's nuts in the very best way. Apparently when he was writing one of his programs or testing one of his systems, he meant to write Hello World and he mistyped it and it was Hellorld, and that just kind of became a thing. And yeah, I think I'm gonna copy that because that's pretty damn hilarious. So I'm going to write a Hellorld script that is just going to print Hellorld to the serial port over and over and over again. So this is the RS-232 device, or adapter for my laptop. So I should be able to plug that in, and when it starts printing, I should see it show up on screen. I'm not going to make you watch me figure out how to program it. I need to figure out how to use this to send the firmware to the MCU. I'll probably bring the camera back when I'm ready to do that, but if things go well, that should really be just like I was doing before when I did my previous programming with the Nucleo boards. This, when I did plug it in before, showed up as a USB device, Dev USB ACM0 or TTY USB 0. And if that's the case, then I should just be able to flash this and it will send the code to the MCU and it'll work just like it did before. For me, I got a little bit of work. For you, here's another magic. So it is 1:30 in the morning. I should probably be going to bed, but I don't want to. Reason for that is, I think I am ready to try to program the board for the first time. So on the top screen here, I have a screen session which is monitoring the output of the serial port. All of this is theoretical, of course. I've written a program that should print data to here, and this is a far stretchier stretch goal, it should actually respond to the switch and turn on all 3 of the LEDs. When I turn off the switch, after a 3-second delay, the lights should go out. The lights at this point don't reflect the relay state at all. I'm just using them as a test. So here's my program, which I have not tried to upload. It compiles. That's all I know at this point. Oh, and you almost fell off there. She's like, I don't know what's going on, but I think I'm going to leave now. How's that for a thumbnail? Make. It compiles. So cat flash. All right, so this should use OpenOCD using the ST-Link DAP config. I don't know if that's going to work for this. Transport select. SWD is single wire debug. Target is the STM32C0, which this is. And then the program I'm going to upload is build blah reset exit. Is this going to work? I don't know. Kind of surprised if it does. No! Target voltage. Oh! It's not powered on. Okay, I can fix that. Okay, so that is on. It is set to 13 volts. 20 amp. I was doing something else with that earlier. I'm going to do current set, bring it down to 0.1 amp. That's probably not enough to stop it from blowing up, but at least it won't go crazy. Let's power it on. May's got the best seat in the house. Is she actually blocking you? Well, that's okay. That's what this camera's for. Okay, let's try this again. Holy shit. It lit up. I'm not seeing anything on the serial port output. And the lights aren't turning off. But it lit up. I didn't expect it to work, and it's not working, to be clear. But that is a very successful not working. Okay, could that just be something? It could just be that the IS-31, well no, because if it was just the IS-31 turning on those LEDs, simply powering it up would have turned it on, and they didn't. They turned on when I flashed it. So this is talking to the MCU. Poorly, but it's talking. High-speed high-speed I2C channel 1 is what I'm using to talk to the IS-31. HUART is how I'm talking to the serial controller. I do have a oh, I'm not doing any DMA. Oh, that's okay. The DMA is on the RX only, and I'm trying to transmit, so that wouldn't matter. I'm not worried about receiving. Oh, of course it's not printing to the serial port. Because all I'm doing is a simple print. Okay, I think I can fix this. I just need to do a little bit of work. I've got to look up the code to make sure I'm actually talking to the serial port properly. I did that in the old code, so I just need to dig up my old code and port it over. I'll bring you back when I'm ready to test again. Heavy noises. I left the board running for a bit, and it was fine. It never heated up. So I think I've got it solved. I mean, I don't know. I brought you back, and if this fixes it, it's a really simple fix, and it's almost too simple, which just makes me think this is going to work, but let's find out together. So I had set up a car buffer, a variable called buffer that's a kilobyte long, and I have to print to that buffer, which should send it to this serial output. But that wouldn't be enough by itself. I also didn't have the new line and carriage return, so maybe not having the new line and carriage return was part of it. Let's find out together. I'm kind of not expecting this to work. Nada. You can't see this on the screen recorder, but I've got in another window the old code. Why is this not working? I am trying now to use the USART transmit. I don't know if any of this is going to work. I don't even really know what this means, but I'm looking online at tutorials. Shit. All right. I have a silly scope. Barely know how to use it at all. Okay, 1 kilohertz. I'm running at 115200. So let's right to 116. What do I even want to touch on? God, I wish I had remembered to put a test probe on for the TX and RX. It's the third line in. I don't know if you can still see that. Hopefully my head isn't blocking it. I don't think I'm using this right. Okay, it's set to auto. It's on channel 1, which is what this is plugged into. The third pin is the USART TX, so there should be a signal coming into the MX or MAX 232 if this is actually printing to screen, but I think I just have a software issue. I don't think it's set up properly. I mean, I don't even know if I'm using this properly. Oh fuck, I have so much to learn. All right, so I brought you back because I think I am making a bit of progress. Now, I realized after I turned off the camera that I had connected the, what should have been the ground. I don't know if it's common or ground, whatever, I'm gonna call it the ground, from the oscilloscope to the isolated ground, and then remembered the whole reason I have the 2 different 5 volts was to power the RS-232 isolator? No, how does that work? Well, anyways, I switched it over to the ship ground. Did I tell you it was late? And I pulled out the pins so I could actually get the other scope probe, channel 1, channel A, whichever, onto the wire. Now this is on the output of the MX or the MAX 232, but assuming the MAX 232 works, I wanted to try grabbing that pin, and you notice, I don't know if you can see, oh, it's coming through, but I'm seeing a blip. Now, the way I've got it set up is, if I go to the code, oh, and this is the pinout for the adapter. I've got the Antaira something adapter. I started wondering if I have the TX and RX lines backwards, which is why I pulled this out and I was looking at the pinout for my USB thingy. So in the code, when it goes into the while loop, I have a HAL delay of 1000 milliseconds. 1, 2, 3. So that seems to be on a 1 second. It's slowly walking across the screen. There's probably some significance to that if I knew what I was doing. It sure looks like it's a bit of data coming in though, doesn't it? So yeah, I'm wondering if I've got my pinout backwards. Let me set this to something stupid. Let's make it 5 seconds and see if that... Actually, I have to get back to the screen I was at before. There we go. Nothing. 1, 2, 3, 4, 5. It's alive. It's not printing, but it's alive. Okay, so the reason I brought this out is I want to reverse this. So currently I have 4 going to is TR transmit receive, and 3 is TXD and DT. I think I might have my cabling wrong here. DTR and DSR. I've got 3 and 4 wired up. I think I've got this USB thing wired up the wrong way. If the Googles are to be believed, I have screwed up the TX and RX lines on the PCB header. On the MX232 chip, pin 13 is R1 in, which goes to pin 3. So that's where it would receive data over the serial bus. So I actually care about this line, which goes to pin 4, which is my gray wire right here. Maybe just connecting the transmit into the receive might work. It might not if where I don't have a ground. Let's see. This gray cable, if that's the case, plug in like that. So I would need to send it to here. Ha! It's alive! It's alive! I know I've got the screen recording going, but come on, focus, focus. Ah! It's alive. I don't have carriage return or line return, but oh my God. I cannot tell you how happy I am right now. Holy shit. Okay. Ah, don't drop the camera. Camera's expensive. I'm going to make an adapter because this is going to be a problem all the time, and I can't do this all the time. Clam. I used the scope. I used it very poorly, but I used the scope and I confirmed there was data. I realized there was probably a wiring issue. I was right. I solved a problem and I didn't ask for help. Let me rephrase. I asked for help, but nobody was available. Totally fine. I don't want to sound like, oh, nobody was there to help me. I had to do this one. No, not at all. I'm actually really stoked. I had to solve this by myself, and I did. Poorly, but I got there in the end. And oh my, okay. Clam. I can't even talk straight. I'm so excited right now. The thing with DIY, and I think if you're not a DIYer, it's hard to explain this feeling. It's when you've been fighting and you've been fighting and you've been fighting and you've been doing all of this work and you have no way of knowing whether it's going to work. I swear to God, I've got to have almost 100 hours. I mean, okay, that's across all the boards and everything like that. Well over 100 hours, working on these PCBs. And through this entire time, I have not actually seen them working. To have that kind of effort and stress and fear and self-doubt and all of this shit in your head building up, and just, you never know if it's going to work. Like, it's not a TV show. In a TV show, they always figure out a way to make it work at the last minute, right? But in real life, that's not the way it is. There's no guarantee that you're not going to fail. So because of that, when it works, even if it's just a simple little hold, it feels so good. I started this channel to show the process of learning, and I've said that many times, but really, if I got down even deeper than that, I started this channel because I want to share this exact moment, this one right now, where you've poured yourself in and you've struggled and you've cursed and you've been depressed and you've been hopeful and you learn new things and that feels good, but it's meaningless until you see it actually work. And it's working. I'm going to go explode now. I'm the Digital Mermaid. See you next time. What are your opinions on this last election and the recent tax policy announcements? You must like the fact that I'm warm. Mm. He's not in any hurry to move. Nope. Oh, we're not paying attention. Now throw your ball. You have to let go for her to throw the ball. Riker.
He doesn't...
He's like, no give, only throw.
He wants to play tug of war.